Okay, this will be your final handout, okay? And there's not a whole lot of material we'll be going over today. There's just a front and a back, and then another separate page of vocabulary. And we'll be utilizing all that, maybe not today. Okay, question was, how many vocab was there? There are 33 terms. Okay? Should they be? Why is that? Some of you, this will be hopefully a good indication on whether or not human anatomy will be for you. Okay? So again, we don't have a whole lot of materials to go over. It's just a lot of work on your part. And I think that's fair because what do we know? Okay? What is the difference between anatomy and physiology? I don't expect you to know, but what do you think the difference is? Well, just take a guess. And if you don't know, that's an answer. Say, I don't know. No. 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 I don't want to hurt myself with just this short amount of time to go. Okay, so as we continue moving forward, yes, one way to look at that would be anatomy is, let's say, any sort of structure that an organism has, whether it's anything from a mammal to a reptile to a fish to a human. Then the physiology is the function of whatever it is you are referring to. So, yes, in a roundabout way, you were correct. And we spend the majority of the time with bones and muscles, okay? So, a couple ways we can introduce this with that of anatomy and physiology. Here we have two of the longest bones in the body, the femur and then that of the humerus, okay? For our purposes at this level, okay, we had said this before, as I'm holding this femur at this level, I think you may have to know maybe just 3 or 4 parts of this bone, okay? You have to know that it's the femur, okay, and maybe condyle and epicondyle. That would probably be about it, okay? But when we look at, for instance, the anatomy of a bone, if you could crack this open, okay, one of the things that you would notice, look at the very bottom. What does that look like? Very bunch of holes, okay? Okay, right? There are 2 components to bone. We call it spongy bone, like you said, lots of holes on the bottom, okay, and compact bone here in the middle, okay? So, when we're talking about anatomy and physiology, the anatomy of this has this corresponding structure where parts of it is this spongy bone where it's hollow, then this compact bone where it's more so solid, okay? So, structure, solid bone, function, what do you suppose? There are 5 functions of bone, and everyone probably can and should be able to think of the most common one for that for bones. Okay, gives the body structure, that's true. You can take quite a bit of a blow on the head because it protects the brain. Yeah. So protection is probably one of the major functions for that of the skeletal system. Okay. In the vital areas, the cranium protects the brain, and the rib cage protects your vital organs. Okay. And so that would be true with that, but it also has secondary functions. Why have these what's called a greater trochanter and a lesser trochanter? In other words, what is it that makes a bone look the way it does? And that's going to be more so of an in-depth physiology of that, because you have cells that constantly reshape your bones. Okay, at any given time, it's kind of like for those of you who've ever overhauled or rebuilt an engine, it's almost like it's rolling off the factory floor. It's brand new again. Same thing with the skeleton. You have cells that constantly reshape this. It eats away some of the tissue and builds it up in certain aspects. Okay? And the reason for that, this provides muscle attachments. That would be another function. It also stores minerals, and if someone has anemia, they may have a type of transplant from something from the bone. It's something inside of the bone tissue. Yeah, marrow. They may have a marrow transplant. So it provides protection, it gives structure, it provides muscle attachment, stores minerals, and it produces blood cells. Those are many of the functions for that of bones. Okay? Then when we look at muscles, well, the most obvious is provides movement, which it does. Okay? So let's say, for instance, it's a little chilly in here, or you say it's a little cold. Well, you might not have a sweatshirt to put on. You might sit here and your arms start moving a little bit and your teeth aren't chattering. It's not that cold. But they also produces heat. Okay? That would be a function of muscle. And even provides a little bit of protection even as well. The reason I say that is if you have a welt, what might a welt be? Especially on the surface of the skin. The muscle got bruised because something inside the muscle ruptured. Be a blood vessel. If that ruptures, then what that does is that creates those different types of hues on the surface of your skin. It starts out as maybe a dark purple. That means there's just a little tiny bit of blood that's pooling at the surface, and eventually goes away as the lymphatic system starts to carry some of them substances away. So with that of the muscular and nervous system, you'll be given besides this vocab that you're going to be responsible for, a list of bones and a list of muscles that you'll be responsible for identification. Okay, so we're starting to wind down. This will be the last portion. I do not believe there's an exam for this. It'll all be included on the final. I believe the majority of it is this one, which is that. Okay? So, with that, I have just a little bit of content to go over. Then the rest of the time will be yours as you make your way down to Mrs. Paulson's. Okay. So, as we proceed forward, okay? Okay, as we had said earlier, muscles contract, so it provides movement, okay? Now, think about how muscles actually do this as you're writing this down. is how many of you, remember I do have a list, and you individuals had wrote or written your names down on that piece of paper as far as possibly taking anatomy and physiology. I've got one, I got 12 names on here, okay? And with that, band would only affect Jordan and then you're not going to take anatomy and physiology. Okay. So then, okay. Fair enough. So with that, if you're in that class, how many of you think you're ever going to get a chance to hold a human brain? Yes. If you take that class, there's a field trip that's why we were gone last week, to go to SDSU, where we have that opportunity to partake in that. Okay, and again, that's something that you will never forget. And of course, there's a reason why to have a class like that, and I think you would agree. How many of you find it very boring to, well, how you measure out using a tape measure, use a square, then use this saw to cut your 2x6, or whether it's dealing that with cooking? It's a lot more, I want to say, satisfying, or a lot more interesting if you actually do the work rather than reading about it. I think you would agree with that, okay? But before we get to that point, we always like to have a good, let's say, background with that. So, with this, okay, composed of cells that contract. Do muscles push or do they pull? We said think about that. Well, it's either one or the other. Okay. Well, what about if you're doing your bench press or your push-ups? Doesn't this muscle push? These back here, called your triceps, they must push that barbell up. Or is there something pulling? It's actually pulling. You were right the first time. You actually pull, okay? And the reason we establish that is when you're talking about muscles, okay, you're responsible for knowing 4 things. The name of the muscle, where it originates, where it inserts, and then what its function is, okay? So if we have this diagram over here, or this skeleton, okay, I mean it's not, okay, so as you have this arm up, okay, as this pushes up, then it's not pushing, it's pulling, okay, it's pulling on the elbow. The insertion is down here, okay, and then the origin is up here, and insertions get pulled towards their origins, and that's how that happens. Same thing with your biceps, okay. You have 2 insertions down here and an origin up here, and that pulls, actually it attaches on the radius and ulna, not the humerus here, and pulls that shorter. So they shorten in the center, and that's why, for instance, when you guys flex your muscles and you say, ladies, look at these big guns here. That gun show was last weekend in Sioux Falls. Now it's up here at school. We've got this gun show going on. Yeah, no. Okay. So regardless, again, muscles shorten. Okay. So they pull. They don't push. All right. So we gave you 2 examples of muscles that are voluntary. Those were what and what? Biceps and triceps. Can anyone give another example of a voluntary muscle? Hamstrings. That's a group of 3, as opposed to the quadriceps. That's the group of 4. But you're right. Okay. And how's we can see that it's different from that of a smooth muscle because it says it's not controlled consciously. So where I wouldn't expect you to know an answer to this, but you might be able to guess, where might you find an example of a smooth muscle in your body? Close. That's cardiac muscle. You had the right idea. It is, you don't have conscious control over it, but it's a special type of muscle tissue. Cardiac is heart muscle. Yeah, and like I said, I wouldn't expect you, How about intestinal walls? How about the walls of your arteries? Your stomach is a voluntary muscle. Your intestines are. Even the muscles, you actually have involuntary muscles in your skin. Actually have little papillary muscles that makes your hair stand up. It actually pulls and makes your hair stand up. Those are also involuntary. There's a whole bunch of those, okay? But when we look at this, getting back, I just happen to see the coordinated fashion. Some muscles are prime movers. In other words, it does the majority of the movement. And then you also have what's called synergists that actually help out, and joint stabilizers. Okay? So, for instance, when you're walking, you're flexing your hamstring group. That's true. But a joint stabilizer is actually your gluteal group, what you're sitting on. Okay? It's that muscle that also flexes. You would not be able to walk without that muscle. It can't move your legs, but it just stabilizes the joint where it attaches. Okay? That's probably a further in-depth definition of what you would want for those, but important nonetheless. So, there's no time frame on when those terms are due. Some point next week. You'll have plenty of time to work on those. So we'll wrap things up now. So power down and make your way down to Mrs. Paulson's room, and we'll catch up to you next time.